Okay, so 7.5 is similar triangles and indirect measurement. Similar triangles, we talked about similar triangles having the same angle measures. And then indirect measurement, we haven't really talked about. But here's the definition of indirect measurement. So it allows you to use properties of similar polygons to find distances or lengths that are difficult to measure directly. So allows you to use properties of similar polygons to find distances or lengths that are difficult to measure directly. Okay, so I'm going to ask you guys like a little bonus question, and if you get it right, you can get a candy, okay? So as you write that down, think about something, an example of something that we would measure indirectly, because something that maybe is hard for us to measure with just like a measuring tape or a ruler. Okay, so when you think of one, raise your hand. Garrett?
Like maybe like a ball or like a bolt or like something that's not easily measured with like a ruler.
Okay, that's kind of what I said, right?
Like if you put it like a granulated cylinder, anything that would like go in there.
Okay, so you're talking about measuring based on density, like Archimedes' principle?
Yeah, like if you were to measure like a rock.
Okay, that would work, and that would be Archimedes' principle, but I'll give you that. So come get a candy. And then anybody else think of something else, maybe something bigger than that we, yeah?
Like maybe like the actual like cockpit of a plane or something like that, since it's curved.
Okay, so you're saying like a structure?
Yeah.
Would we have something to compare that to?
What do you mean in comparison?
Well, like if we have something that says similar polygons, do you think we'd have something similar?
A circle? No, a circle's not a polygon.
Yeah.
Not like that.
Not like that. Not quite. I'm thinking even bigger, like much bigger. Yeah. The Earth. Good. So how do we measure things on the Earth?
With satellites.
Satellites, right? We use satellites. Do you want a candy, Morgan? No, but thanks for participating. Do you want a candy? You're just doing candy. Okay, so things like that, indirect, right? And we can use similar things, things that we already know about to measure other things, okay? So if we're looking at calculus, for instance, and we're measuring the curve of something, like a roller coaster, okay? And we know that we can measure a curve, but it's not a straight line or anything. That calculus would be an indirect measurement, okay? So things like that. All right, we have this, it's not really a proof today, and if you're taking a full year of geometry, you would get a whole long page about this, but basically, I'm going to give this to you in a sentence. But we have angle, angle, AA, similarity, okay? This is like a proof to say that two triangles would be similar if two of their angles were the same, okay? This is on the test. There is a question regarding this, so you do need to write this down to make sure the test is open note, so you can refer back to this. So if you want to put a star next to it or something like that, that would be fine. So if two angles of one triangle are congruent to two angles of another triangle, then you can say that the triangles are similar. So you're just looking like for two matching angles in each triangle, okay? And then you could make a statement. And I put some examples here for you guys, like a little drawing to show you what I mean. And the test is like this too. So they'll give you two triangles, and you just have to state what makes them similar, and you could just say AA, similarity, and you would get it right. You don't have to write the sentence. So basically in these two triangles, we have A, B, C, and we have G or F, G, H, I guess. We'll go alphabetically. And remember these little arc signs? That represents congruence. So the proof is kind of comes from this. So if you have two angles that are congruent, will the third angle also be congruent? What do you think? If you have 2 out of 3 angles, will the third one be the same? Yeah, because they add up to 180, right? It's not like one triangle adds up to 190. So that's where it comes from. So you only need 2 angles to prove similarity. And these are the congruent statements, right? So angle A is congruent to angle F, and angle B is congruent to angle G. Then the triangles are similar. That little symbol means similar. Any questions so far? It's pretty simple. Okay, so remember, if you get 2 congruent angles, you can say, yep, they are similar. Okay, and then the bit about indirect measurement, there's a problem in your book that is much better, but I just kind of wrote down like a little, I don't know, a little bit of the information, but I'll show you what it looks like in the book. So if you want to write indirect measurement, and then on page 555 there's a problem. Obviously it's done better than my beautiful drawing here. But I'll show you guys the book real quick. So a lot of times when they do indirect measurement, they do things like using shadows. So you're going to get problems where there's like a shadow of a light or a tree or the sun, something like that. They use shadows in indirect measurement, okay? So if we can suppose that the sun is at the same angle when we're measuring it, or a street light is at the same angle when we're measuring it, then we can do that. So I'm going to show you the picture real quick. You don't have to draw mine if you want to just write down page 555. But basically it looks like this. So this one is a street light, and then there's a fire hydrant, and there's a shadow of 26 feet here, and a shadow of 5 feet here. You guys see that? And then we don't know the height of the street light, but we know the height of the fire hydrant. So you just set it up like a ratio, okay? So 5 to 26, so that's the shadows, right? Equals 2.5 to h. And then remember how you cross multiply and then you divide to get this? You guys remember doing that? So just when you set it up, you want to make sure you're setting it up correctly. So if we're going base to base or shadow to shadow, then we do height to height, okay? But it has to go in the same order. So see how they have hydrant on the top, street light on the bottom? Could you put street light on the top and hydrant on the bottom and get the same answer? Yes, okay? It doesn't matter if you did smaller number over bigger number or bigger number over smaller number, as long as you keep the same order, okay? So we're going to do quite a few of these types of problems. All right, so that's that one. So basically what you guys want to do is cross multiply and divide. Now some people are like, well, I already know that 2.5 is half of 5. Did anyone see it that way?
Yeah.
And so then they're like, well, half of 26 is 13. So some of you guys are really good with those proportions and ratios, but they're going to get bigger, and then they're going to get to be where they're like decimals and stuff, so probably not going to just know those ones in your head, right? So you do have to know the math behind it, which is the cross multiply divide stuff. I'm not going to spend a lot of time teaching you guys to cross multiply and divide, because I know that you did that in 6th and 7th grade quite a bit. So if you're not sure how to cross multiply and divide on these problems, just come up and ask me later. Do you guys think my drawing's better or the book? Who said yours? You're getting an A.
Whichever one,
Good job.
whichever one gets me.
Yeah. Angie said it first, so she gets the A.
Yeah.
Okay. Anyway, you guys get the gist of it. So you're just comparing, basically. So that's indirect measurements using these shadows. If you want to refer back to your book or like cut that page out and glue it in, that's fine with me because, you know, my picture is not very... And I didn't write out the whole question clearly, right? All right, can I go to the next page? You can look back on your book if you want more of it later. Okay. So, this is another example. This actually occurs a lot more when you see geometry type problems. They take a big triangle like this and they'll split it. So it's like one big right triangle and then they'll put a line down the middle here and make a smaller right triangle. This is pretty common. This is from your book, but this is like a lake right here if you want to look back. It's on the same page. So we have the length of this as 320 meters. The length of this one is 162 meters. And then this piece here is 40 meters. And then we don't know this one. We'll call it D. D meters. So you can see, can you guys see it's a smaller triangle inside of a bigger triangle? Do you guys all see that? Okay. So we're going to use the smaller triangle to find the missing piece of the bigger triangle. That's all we're going to do. So it's a basic proportional setup. So raise your hand if you have an idea of what I should do to set it up. Anybody out there have any ideas? What can I compare? Which pieces could I compare? What do you think?
Like angle A and B and then B and
Oh,
C.
line segment?
Yeah.
A and B and C to what?
The angles on the bottom, A and, or not angles, lines, A and D.
40 and D. Okay, any other ideas out there? You're close. You're really close. Anybody? Why do you think I put this line like that?
Well, I don't know.
Okay, what?
Maybe if you compared A and C to A and B.
A and C and then A and B?
Yeah.
And then this one and that one?
Yeah.
Yep. So here's what you do. To find D, you compare AB, which is this piece, to BD. So think this is the smaller, right? The smaller triangle. That's what we're looking at first. So we have the smaller pieces of the triangle, so 320 to 40. And then the bottom of that, to fill out our ratio, is going to be AC, so the whole piece over CE. So it's kind of like part to whole, part to whole, if you want to think of it like that. You're going to get a couple more of these today, so you can practice. So AB is just 320, right? What's AC? What's A to C?
Like length or?
Yeah, what is this?
482
482.
meters.
Good. So we have 320 over 482. So you add the two together, right? And then 40 over D. Okay, and then I multiplied. So 40 times 482 is 19,280. 320 times D, and then divide by 320. And you get 60.25 meters.
Or you could see that 40 times
You
8
could do that too,
is 320.
right? But it's still, you're going to end up with a decimal, so better to cross multiply and divide. Now, I have a question for you guys. Would you be finished at this point? Do we have D?
Yeah.
Should we check and make sure that it makes sense?
Yes.
Because there's so many times I get these, and like this will be 40, and someone will write D equals 3. Does that look like a 3 if that's a 40? Clearly we know this length should be bigger, right? But so many times people just write the answer and they're like, I'm done. Right? So you should check to make sure it makes sense.
Could you check with the Pythagorean theorem to get A and E and see if it works?
If you wanted to. But you'd have to use this one first to get that piece, right?
Mm-hmm.
And then you have to figure out this. It'd be really hard. So basically do it this way, okay? So I just want to get across to you guys that the number sense here that's happening, a lot of you guys are still developing your number sense. But like if I give you a problem and it says find the height of the tree, and you put the tree as 2 feet tall, and there's a 5-foot man standing next to it, do you think that that would be accurate if the tree in the picture looks bigger than the man and you put 2? Or what if I tell you to find the height of a building and you put it's 5 feet tall? Do you think maybe you should go back and always check and make sure it makes sense? That would be a good idea. But I'm telling you this now, and I know half of you won't do this, right? Just go back and check. It only takes a second. Okay? Alright, so the practice that I want you guys to do is in your book. It's 556, 1 to 4, and 557, 3 to 6. So go ahead and turn to your book.